A measuring rod is laid along the ground, lifted, set down again where its far end came to rest. Lifted, set down, end over end, until it reaches a second point, and the count of those liftings becomes the distance between them. Nothing more elaborate than this act underlies every later claim about what things are and how far apart they stand. Carved into the oldest geometry are propositions that have gone unquestioned for centuries, that a straight line is determined by 2 points, that parallels never meet, that a triangle's angles sum to 2 right angles. Each follows from the one before it by a chain of reasoning so tight that to doubt the conclusion, while granting the premises, feels like a kind of madness. And yet the premises themselves, the axioms, sit beneath that chain, untouched by it, and a strange thing happens when they are pressed. The question of whether they are true turns out not to have a false answer, but no answer at all. Geometry, on its own terms, speaks only of points and lines and the logical relations among them. It makes no promise that any of this corresponds to a rod, a wall, a stretched wire. Truth, in the sense that matters outside a textbook, means correspondence with something real. And pure geometry, left to itself, touches nothing real, but a single addition changes everything. Take 2 marks on a body rigid enough to keep its shape, and declare that the distance between those marks stays the same, whatever journey the body is carried through, however it is turned or set down elsewhere. The moment that declaration is made, the propositions of geometry stop being statements about ideas and become statements about the possible arrangements of rigid bodies. Geometry has become a branch of physics. Its truth can now be tested with rule and compass against the rod itself, though that testing rests, in the end, on nothing more certain than experience. A place can be named without any of this. Times Square, New York, identifies a point on the rigid body called the Earth, and that is often enough. But a cloud hangs over the square, belonging to no surface, and the naming fails until a pole rises from the pavement to the cloud, its height read off in lengths of the standard rod. The pole need not exist to do its work. The cloud's position is given the moment its height is known. From this single refinement grows the full apparatus. 3 plane surfaces, rigidly joined, perpendicular to one another, and any event anywhere assigned its place by 3 lengths. 3 rods laid down along 3 perpendiculars, dropped from the event to those 3 planes. At the window of a railway carriage, moving smoothly along its track, a hand opens and a stone falls. Disregarding the air, the eye at the window sees it descend along a straight line, falling exactly beneath the hand that released it. On the footpath below, another eye watches the same fall and sees a curve, a parabola. The stone advancing with the carriage, even as it drops. The same stone, the same instant of falling, two shapes, neither one the imposter. There is no path belonging to the stone by itself, only a path belonging to the stone together with whatever body, carriage, or embankment the watching is anchored to. A law stands at the center of mechanics. A body far enough removed from every other body persists in rest or in motion along a straight line at constant speed. Stated this plainly, the law seems to describe only bodies. In fact, it does something else as well. It quietly sorts the frames from which motion can be watched, declaring some fit for its purposes and others not. Fix a frame to the spinning earth and the fixed stars. Bodies about as free from outside influence as anything known are seen to sweep enormous circles across the sky once a day, in flat contradiction of a law that promises them rest or straight uniform motion. The stars have not betrayed the law. The earth-fixed frame has disqualified itself. Among the frames in which the stars do not circle, the law holds, and a frame in which it holds earns a name, Galilean. A raven crosses the sky on a path straight and even, watched from the embankment, watched instead from the carriage, gliding without turning, at its own constant speed. The raven's path is still straight, still even, only its speed and direction have changed. Whatever is true of one Galilean frame turns out to be true of any frame moving uniformly relative to it, without rotation. The same general laws, unaltered, in neither one. No experiment performed wholly within a closed carriage could ever betray, whether the carriage was moving or standing still, a tenet broad enough to be called a principle, the principle of relativity in its restricted form. Classical mechanics, whatever its limit, renders the wanderings of the planets with a precision close to wonder, and a principle holding so exactly within one domain of nature is not the kind of thing expected to fail elsewhere without a trace. Were it to fail, were one frame, among all those moving uniformly, secretly entitled to be called the one truly at rest, then the laws written for any other frame would have to carry some mark of that frame's motion through the privileged one. An organ pipe might sound a different note pointed along the direction of travel than across it. The Earth itself, circling the Sun at some 30 kilometers each second, changes the direction of that motion continuously through the year. And if a privileged frame existed, that changing direction ought to leave some trace. One direction in space behaving differently from another. No such trace has ever been found. Every direction tested has behaved exactly like every other. What survives, once geometry has needed a rigid body to mean anything, once a place has needed a body to be named against, once a falling stone has needed a body to be either a line or a curve, once even rest and uniform motion have needed a whole family of equivalent frames to make sense. What survives is not a stage on which all this occurs, but only the bodies themselves and the relations measured between them. Space, examined honestly, was never a container. It was always this: rods, carriages, stars, the turning earth, and the distances and motions read off between them. A man crosses the floor of a moving carriage, walking from one end toward the other, while the carriage itself runs the rails at a steady speed. Two motions are present at once: the carriage's own progress against the embankment and the man's progress against the carriage's floor, and the question of how fast he travels relative to the embankment outside seems to answer itself before it is fully asked. In the span of 1 second, the carriage carries him forward by its own velocity, and his walking carries him forward by his own velocity again, and the embankment receives the sum of both. Add the two figures, and the answer stands. Nothing about this arithmetic has ever needed defending. It has held for every cart, every ship, every thrown stone. Then replace the walking man with a beam of light, sent down the carriage in the direction of travel. The same arithmetic applies, or seems to. Light crosses empty space at a fixed pace, something near 300,000 kilometers in a single second. The same pace for every color, a fact written into the sky itself. When a star vanishes behind its dark companion, every color of its spectrum dims at the same moment, none lagging behind the others, as it would if the faster colors outran the slower across the gulf between. Pairs of orbiting double stars settle the matter further. As De Sitter showed, light leaving a star racing toward the Earth arrives no sooner than light leaving its twin racing away. The speed belongs to the light itself, never to whatever sent it. But subtract the carriage's own velocity from that fixed pace, as the arithmetic from a moment ago demands, and the beam, measured from inside the carriage, must travel slower than light. A second law, just for the carriage, just for this one frame, would have to be written to account for the shortfall. Yet nothing sealed inside a carriage can ever betray its own motion. Every law inside must read exactly as it does outside. Light cannot move at one pace for the embankment and another for the carriage, while both obey a single shared law. Something beneath the arithmetic itself has given way. What gives way is an assumption never stated because never doubted, that at the same time needs no defining, that a flash here and a flash there either happen together or do not, plainly, for everyone. Pressed on this, the difficulty becomes visible. Simultaneity is not a fact lying ready to be read off the world, but a measurement that must first be built, and only one construction makes the building possible. A point midway between two distant places. Call it M, equipped with a pair of mirrors, angled to catch light arriving from both directions at once. If both arrivals register together at M, the two events that sent them are simultaneous. By definition, rather than by discovery. To carry this definition across an entire reference body, clocks of identical construction are set at every point along it, at A, at B, B at C and everywhere between, each adjusted so that its hands agree with its neighbours under that same rule. Whatever a clock then reads, at the instant nearest an event beside it, becomes that event's time. Now, lightning strikes two distant points along the rails, one at A, one at B. At the same instant, by this very definition, judged from the embankment, light from each strike reaches the embankment's midpoint M together. But a train runs along those same rails, and a second point, M prime, sits at the midpoint of the same stretch as marked off along the train's own length. At the instant the two flashes occur, M prime coincides exactly with M, but M prime is already moving, carried forward at the train's own speed, hurrying toward the light still travelling from B and retreating from the light still travelling from A. The beam from B arrives at M prime first. Whoever rides the train, trusting what reaches them, must conclude that B happened before A. Embankment and train, applying the identical definition with identical rigour, arrive at opposite verdicts about the same two flashes. Neither is mistaken. Each reference body carries its own time, inseparable from its own motion, and a statement of when means nothing until the body it is measured against is named. The same dissolution reaches distance, a length read off along the floor of the moving train. The span, say, between its first carriage and its 100th, is measured there directly, rod laid against rod, end over end. The same span, measured instead from the embankment, requires marking where each end of that span happens to sit at one single embankment instant. And at one instant, for 2 points already in motion, is exactly the notion that has just come apart. The length of the train, depending on which body does the measuring, need not agree with itself. Light keeps its single, unyielding pace through every reference body. The present does not. What had seemed the most secure of all certainties, that some shared now stretches across the universe, equally true everywhere at once, turns out to be no more than a habit of thought, resting on a definition that was never examined until the moment it broke. Two grids of rods now cover everything. One belongs to the embankment, stretched in every direction until it has no edge. 3 families of perpendicular planes laid down without limit, so that any event anywhere can be caught between them and given its 3 lengths and its 1 moment. The other belongs to the train, the same lattice of rods carried along at the train's own speed, extended just as far, just as completely, so that the same event, wherever it occurs, can be caught a second time and given a second set of numbers. Nothing about the event has changed. Only the grid doing the catching. Beneath the trouble that split the lightning at A and B, 2 assumptions had been resting all along, never stated because never doubted. The first, that the interval of time between 2 events is simply what it is, the same number no matter which grid does the measuring. The second, that the distance between 2 points of a rigid body is simply what it is, untouched by whatever that body happens to be doing. Both assumptions are old enough to feel like bedrock. Both are now set down and looked at directly, and neither survives the look. Drop them, and the contradiction that seemed to demand a light ray slower from inside the carriage than from outside it no longer follows from anything. The arithmetic of added velocities was never wrong on its own terms. It was built on a flaw that was never there. What remains is a question stripped to its bones. Given the place and moment of an event on the embankment's grid, what place and moment does the same event receive on the train's grid? Under the one condition that a ray of light, measured either way, comes out at the same fixed speed. The question has an answer, exact and singular, and the answer is a transformation, a rule converting one set of coordinates into the other, built so that light's pace survives the conversion intact. It bears the name of the man who first wrote it down, the Lorentz transformation. Inside it, space and time are no longer handled separately. The new position depends a little on the old time, and the new time depends a little on the old position. Woven together in a way the older arithmetic never imagined. That older arithmetic has not vanished. It sits inside the new rule as a special case. The shape the Lorentz transformation takes if the speed of light were allowed to grow without limit, swelling toward infinity until it ceases to constrain anything at all. Send C to infinity, and the elaborate weaving of space and time falls apart back into the old, simple, separate bookkeeping, the Galilei transformation, the rule that every cart and every thrown stone has always obeyed closely enough to never notice the difference. A rod a meter long lies along the train's grid, one end at the origin, the other end a meter further down the line. Asked for its length on the embankment's grid. Where is each end at one single embankment instant? The Lorentz transformation gives an answer smaller than a meter, smaller by a factor. The square root of 1 minus the square of the train speed divided by the square of light speed. The faster the train, the smaller that root, the shorter the rod. At the speed of light itself, the root reaches 0, and the rod, measured from the embankment, has no length at all. Past that speed, the quantity beneath the root turns negative, and the square root no longer corresponds to anything real. The line cannot be crossed. Light's speed stands revealed not as a property of light alone, but as a ceiling built into the grammar of motion. A limiting velocity, no rod, no clock, no body of any kind can reach or pass. A clock sits at the origin of the train's grid, ticking out its seconds. From the embankment's grid, watching the same 2 ticks arrive, the interval between them is no longer 1 second, but 1 second, divided by that same shrinking root. A slightly longer wait. The moving clock running slow, falling further behind the longer it runs. With the same unreachable ceiling waiting at the same speed. Such speeds are nowhere near the speeds of carts or trains, and the shrinking of rods and the lagging of clocks remain, for ordinary motion, immeasurably small. Yet the theory does not rest on that admission alone. Decades before any of this was written down, a tube of liquid had already been made to answer a related question. Light moves through a still liquid at some fixed pace. Set the liquid flowing through the tube, and how much does the flow carry the light along with it? The old arithmetic gives one answer: simple addition. The new transformation gives another, slightly smaller. The flow's contribution diminished by a factor tied to the liquid's own refractive bending of light. Fizeau's tube, run and rerun by careful hands, came down on the side of the new answer. Siemens' later measurements pinned the agreement to within 1 part in 100. A purely electrical theory of matter, built independently and earlier, had reached the same prediction by its own road. Not a rival to the new picture, but a tributary feeding into it, absorbed rather than discarded. What the transformation finally yields is not only a set of corrected numbers, but a demand placed on every law of nature still to be written, stated in the embankment's coordinates or the trains. A true law must keep exactly its own form, neither gaining nor losing a term in translation. A law that failed this test would betray that something in the foundation, the constancy of light, or the equivalence of every uniformly moving frame, had been wrongly assumed. None has failed it yet. The speed of light, then, is not a fact about light. It is the rate at which the conversion between any two uniformly moving grids must be written, the hinge the whole structure turns on. And a rod growing shorter, a clock running slow, are not distortions imposed on an otherwise normal world. They are the toll, paid in full and exactly by every moving thing for the privilege of living in a universe where light's pace never varies. Energy pours into a moving particle without end, and the particle answers less and less. At ordinary speeds, the old reckoning holds. Push, and velocity rises in step with the push, as it has for every cart and stone ever set in motion. But far enough along, the step falters. More energy buys a smaller gain. Further still, the gain shrinks toward nothing, though the energy poured in does not. Drawn out as a sum of terms, the new expression for that energy agrees with the old familiar one in its second term. The term classical mechanics had always been content with, but carries a third term beyond it, small at ordinary speeds, swelling without limit as the speed climbs toward the one ceiling nothing crosses. No matter how vast the expenditure, the particle approaches that ceiling and never reaches it. There is a first term too, standing before the others, untouched by velocity altogether, present even when the particle is perfectly still. For a long while, it asks for no attention, a constant that drops out of any calculation, concerned only with how energy changes as speed changes, but a constant constant that survives even at rest is not nothing. It is waiting. Two laws had stood in physics as separate pillars, each guarding its own ledger. Energy, conserved in every exchange. Mass, conserved in every reaction, untouched however violently a body was struck or heated or set ablaze. The principle of relativity, applied to the conservation of energy, asks that the law hold not for one frame alone, but for any frame in uniform motion relative to another. And the transformation carrying one frame's bookkeeping into another's is no longer the simple addition of the old arithmetic, but the one that bends space and time together. Worked through, a body bathed in radiation, absorbing it, taking it in without otherwise changing its motion, comes out the far side carrying more energy than it held before by exactly the amount absorbed. And worked through again, that same body now behaves, in every mechanical sense, as though its mass had grown by the absorbed energy divided by the square of light speed. The two ledgers turn out to be one ledger, a system that neither sheds nor takes in energy, keeps its mass fixed. For exactly the same reason it keeps its energy fixed, because the two statements have become the same statement. The waiting constant, the term that survived even at rest, was mass all along, written in the currency of energy. No scale built can catch this directly. The energy released by ordinary processes is too faint against the mass already present for the difference to register. And classical physics, working only with such processes, never had reason to doubt that mass stood apart, eternally itself. The error was never in what was measured. It was in what the measurement was too coarse to reveal. Something else falls with this unification, quieter, but no less final. Gravitation, in the old picture, reached across empty space instantly. A pull felt the moment a distant mass shifted, with nothing carrying the influence between. Electric and magnetic forces had already given up that picture decades earlier, replaced by a field that fills the space between charges and carries influence at a finite pace. The new mechanics extends the same demand to everything. No influence crosses a gap untouched by time. Whatever travels between bodies travels at the one speed that governs the conversion between frames, and not faster. A medium had once seemed necessary to carry such influence. A substance filling all of space, motionless, against which every other motion could finally be measured. Two mirrors, facing each other along a rigid frame, were built to catch it. A ray of light sent down one path and back again should take a slightly different time than the same ray sent along a perpendicular path. If the frame itself were ploughing through this stationary medium at any speed at all, the difference, though minute, lay well within reach of the apparatus. The result came back flat. No difference. The instrument, oriented one way and then turned through a right angle, returned the same time. Either way, as though it were not moving through anything. A contraction contraction was proposed to save the medium. The apparatus itself shortened in just the direction of its supposed passage, by just enough to erase the very difference it had been built to find. The figure required for that shortening matched, term for term, the contraction already demanded elsewhere by the new mechanics. But where the old explanation needed a hidden medium and a motion against it, that could never be detected by any other means, the new one needs neither. There is no frame uniquely at rest. The contraction belongs not to motion through anything, but to motion relative to whichever frame does the measuring. For a frame moving with the apparatus, nothing shortens at all. The medium had never been required. Light arriving from the stars shifted in color by the motion of its source, and the bending of starlight's apparent direction through the year, both already accounted for without it, now stand as evidence with nothing left for a stationary medium to explain. The fast, light-bent particles thrown off by radioactive matter follow the same mechanics, needing no separate hypothesis about their shape or substance. The space between things turns out to be empty in the fullest sense. Empty, even of the one thing once thought indispensable to it. Space itself, meanwhile, has never needed defending as a continuum. Any point near another can be reached by numbers only slightly different from the first. 3 numbers sufficing for any point, and that sufficiency is the whole of what 3-dimensional means. The world of events admits exactly the same description, except that 4 numbers are needed instead of 3. 3 for where, 1 for when. And any event has neighboring events, earlier or later, displaced by ever smaller amounts in all 4 figures at once. Classical mechanics had always granted the first 3 numbers this continuous, seamless character, while setting the 4th apart, ticking the same for every frame, regardless of position or motion, untouched by anything happening in space. But the transformation that already reshapes length and duration between frames does not leave time isolated in its corner. A pair of events separated only in space for one frame, no time between them at all, acquires a separation in time for another frame, moving relative to the first. Spatial distance, carried across the transformation, becomes partly temporal distance. The 4th number no longer stands apart, recast with time, measured in the same units as the other 3. Through a quantity built from light speed and an imaginary factor, the 4 numbers describing an event take on, formally, the same character as 3 ordinary spatial coordinates. In the geometry already known, the recasting changes nothing about what happens. It changes what the happening looks like. Not 3 dimensions plus a separate ticking, but a single 4-dimensional fabric. Every point on it, an event. Every neighboring point, another event close by in space or close by in time. Or both at once, with no longer any principled way to say which. What had stood as 3 separate boundaries, mass against energy, the filled space of a medium against the emptiness around moving bodies, space against time, dissolve, each in turn, into something that was never two things to begin with. Only one thing examined from positions that happened not to agree. The mass at rest was energy waiting. The medium was nothing waiting to be subtracted. And the fourth coordinate was never independent. It was the other three, wearing a disguise that motion alone could see through. A single four-dimensional fabric now lies where 3 dimensions and a separate clock had stood, woven, settled, complete. And onto that fabric, still untouched, one thing remains to be written. The shape it takes when something massive rests upon it. A chest drifts in a region far from every star, so far that nothing pulls on it from any direction. Inside, an observer floats free of the floor, tethered to it by strings, because the smallest push against any surface sends him drifting slowly toward the opposite wall. Nothing here has a top or a bottom. A dropped object does not fall. It simply continues, motionless relative to the hand that released it, hanging in the air of the chest exactly where it was let go. This is what the absence of gravity looks like from the inside. Not emptiness, but the failure of anything to prefer one direction over another. Elsewhere, on a railway, long since familiar, a carriage runs smoothly along its track until brakes are applied, and the body inside lurches forward. A sudden, unmistakable shove with no visible cause. The carriage and the embankment had stood as equals before, each entitled to call itself at rest, while the other moved. But this jerk seems to belong to the carriage alone, a fact about its own motion that the embankment does not share, as if non-uniform motion carried some reality the smooth gliding before it had lacked. The question hangs unresolved, whether some motions are absolute after all, exempt from the equivalence that uniform motion enjoyed. A stone, released from a hand, falls to the ground, and the falling is no longer pictured as the earth reaching across empty space to seize it. Between the earth and the stone lies a field, the way a magnet fills the space around it with something that then acts on a piece of iron, without the magnet touching the iron directly. The earth fills its surroundings with a gravitational field in just this manner, and the field, not the earth itself, not some instantaneous grip across the gap, is what closes around the stone and draws it down. The field weakens with distance by a law as definite as any in physics, and whatever happens to the stone happens because the stone sits inside that field, not because the earth has reached for it. What makes this field unlike any other ever measured is what it does to different bodies. A piece of lead and a piece of wood, released together in a vacuum, fall side by side, neither outpacing the other, as if the field could not tell them apart. Ordinary mechanics already carries the means to say why this is strange. Force equals mass times acceleration. where the mass measures a body's resistance to being moved at all. It's inertia. But force also equals a different mass, a gravitational mass, multiplied by the field's own intensity. A mass measuring how strongly the field takes hold of the body. Almost a kind of weight rather than a kind of stubbornness. Nothing in principle ties these two masses together. A body could resist acceleration fiercely while the field barely noticed it. Or the reverse. And yet, for lead, for wood, for anything ever tested, the two masses come out equal. To every precision measurement has reached, the ratio between them is the same number for everything in the universe. Back inside the drifting chest, a hook fixed to the outer lid takes hold of a rope, and something beyond the chest begins to pull, steadily, with a force that never varies. The chest accelerates. The man inside feels the floor press up against his feet with a force that grows and grows, indistinguishable from standing in a room on solid ground. He releases an object from his hand, and it no longer hangs in the air. It falls toward the floor, gathering speed at exactly the same rate, no matter what the object is made of. Every observation available to him matches what would be observed at rest in a gravitational field. He concludes reasonably that the chest is hanging still, suspended somewhere, held against the downward pull of such a field by the very rope and hook he now notices fixed to the lid. Nothing in his reasoning can be faulted. The acceleration that, from outside the chest, is a body being hauled through empty space by a rope. It's, from inside the chest, a body at rest in a gravitational field. Both descriptions account for every observation available to the observer who holds them. A suspended weight hung from a second rope inside the chest pulls that rope taut, and the man inside names the cause. The gravitational mass of the weight, dragged downward by the field, balanced against the rope's tension. An observer outside, watching the chest accelerate, names a different cause for the identical tension. The inertial mass of the weight, resisting the chest's acceleration, dragged along by the rope. Two names for one tension, two masses that have already been shown to be the same number, and the equality that seemed merely a curious coincidence among falling bodies turns out to be the very fact that allows acceleration and gravitation to trade places without anything detectable being lost. The jerk in the braking carriage finds its answer here. Nothing requires that jerk to be read as the carriage's own acceleration breaking some hidden symmetry. It can equally be read as the sudden appearance of a gravitational field, pointing forward, gripping the carriage and everything in it. While the embankment, under the influence of that same field, is what slows. The carriage remains entitled to call itself at rest, even through the braking, exactly as it was entitled to before. No motion, uniform or not, carries a reality that some reference body lacks. What changes from frame to frame is only whether a gravitational field is present, a question once pressed hard against this picture. why some frames of reference should be granted privilege over others for no visible reason, as if two identical pans on a flame behave differently with nothing beneath one of them to explain it, dissolves along with the privilege itself. Every reference body, accelerated or not, becomes equally fit to carry the laws of nature, provided only that the gravitational field appropriate to it is reckoned in. A field equivalent to acceleration must do everything acceleration does, including bend the path of anything that crosses it, light included. Inside the accelerating chest, a ray of light entering through one wall travels in a straight line as judged from outside. But the chest itself is rising to meet it, so that, judged from inside, the ray arrives lower on the opposite wall than the point directly across. Its path, traced inside the chest, is a curve. Since the chest's acceleration is equivalent to a gravitational field, the same curvature must belong to light passing through any gravitational field at all, including the field of the sun. The bending is slight, but for a ray grazing the sun's edge, it comes to a definite figure. 1.7 seconds of arc, large enough that starlight passing close to the sun during a total eclipse, when the glare no longer drowns the nearby stars, or to show stars displaced outward from their ordinary positions by exactly that amount. And buried in this same result is a quieter consequence. A ray of light cannot bend unless its speed varies from one point to another along its path. The constancy of light's speed, the very rock on which the earlier transformation was built, holds only where gravitational fields are weak enough to be ignored. Near the sun, it no longer holds unconditionally. A disk spins steadily in a region where, for anyone not rotating with it, no gravitational field exists at all. An observer seated somewhere off its center feels a force pulling outward, and by the same reasoning as the chest, reads that force as gravity. A field that vanishes at the center and grows stronger toward the rim. A field with no counterpart in any field ever generated by a mass under Newton's law, yet a field all the same to the observer who lives inside it. Two identical clocks are set down, one at the center, one at the rim. The rim clock is in motion, and a moving clock runs slow. So the rim clock, ticking inside its own gravitational field, falls steadily behind the center clock. A measuring rod laid along the rim, tangent to the circle, is a moving rod, and a moving rod shortens. So the rod laid along the circumference reads short, while the same rod laid along a radius, where no such motion acts, keeps its full length. Circumference measured in the short rod, divided by diameter, measured in the unshortened one, comes out larger than the ratio every flat surface has ever returned. The disk's geometry no longer obeys the rule that has governed every marble floor and every drawn circle. Since the axioms were first written down, and where a circle's own ratio no longer holds, the idea of a straight line too no longer has anything fixed to mean. A constant pull through empty space and a body at rest on the ground. turn out to be the same fact, read by two observers who happen to stand in different places. Wherever that fact holds, wherever a gravitational field is present, real or born of acceleration, the flat geometry that measuring rods were always assumed to obey gives way. Squares stop closing, circles stop keeping their ratio. The rod, laid down as it has been since the first chapter, returns an answer no longer guaranteed by Euclid. Geometry itself, it turns out, was never separate from the field, and a field that bends geometry is not something sitting within space. It is what space, in the presence of mass, becomes. A marble table holds its surface out, flat and pale, and a great number of small rods, each tested against the others until none overlaps its neighbor, each declared equal to all the rest, are laid down 4 at a time, edge to edge, until they close into a square. A fifth rod, shorter, crosses corner to corner. Its match crosses the other way, and the two are held against each other to confirm they agree. Where one square ends, another begins, sharing the rod it touches, until the whole slab lies checkered. Corner meeting corner, 4 squares to every joint. It is not a small thing that this can be done at all. At any meeting of 3 squares, 2 sides of the 4th are already fixed by what surrounds it, and the diagonals of that 4th square are no longer free to be adjusted. They come out equal, or they do not. And if they do, it is a kind of grace. Nothing forced, nothing arranged. Where the slab allows this again and again, corner after corner, square after square, the surface is declared a thing the little rods agree with completely, a Euclidean continuum. And from one corner chosen as origin, every other corner can be named by nothing more than 2 counts. So many rods to the right, so many upward. Now the same slab is heated, but only at its center, its edges left cool. 2 rods brought together anywhere on the table still match each other. The heat has not broken that, but the squares will not hold. Rods at the center swell. Rods toward the rim do not. The quadrilaterals that closed so cleanly before now strain and gap, and the diagonals that came out equal by grace now refuse to agree. Cartesian counting, so many rods right, so many up, no longer reaches every corner by the same simple rule. The slab has become, with respect to these rods, a continuum no longer Euclidean, and yet a small patch near the center, where the temperature barely varies from one rod's length to the next, still looks as flat and orderly as the whole table once did. The disorder is there in the whole, invisible in the part. What rescues such a surface from being merely unmeasurable, is a method that does not ask the rods to form squares at all. Across the slab, a family of curves is drawn, arbitrary in shape, each given a number, packed so densely that between the curve numbered 1 and the curve numbered 2 lie infinitely many more. Every real value between them, covering the table without a single point left out, without any two curves crossing. A second family crosses the first the same way. Every point on the table now carries 2 numbers, 1 from each family, and a point such as the one lying on the curve numbered 3 of the first family, and the curve numbered 1 of the second is named completely by that pair, 3 and 1, with no claim that the curves are straight or perpendicular, or anything but a bookkeeping laid over the surface. Between any point and its near neighbour, the actual distance, read off with the little rod, comes out as a small quantity built from the small differences in those 2 numbers, weighted by factors that themselves shift from place to place across the table, factors that encode point by point how the rods behave there. Only where the surface is truly flat do those weighting factors fall away to nothing, leaving the distance as the plainest sum of the 2 differences, squared and added. The marble slab secret, written as an equation, true whether the slab is flat or buckled or scorched at its heart. This is the method that had already been waiting, worked out long before for curved surfaces in the abstract, pointing the way toward continua of 3 dimensions, 4, any number, and the 4-dimensional fabric of space and time, the one assembled when mass and energy, ether and vacuum, space and the separate tick of time all dissolved into each other, now stands in exactly the position of that marble table. Under the earlier theory, where no gravitational field bends anything, that 4-dimensional fabric had behaved like the cool, untouched slab, its own peculiar distance, built from the 3 spatial separations, and an imaginary multiple of the time separation, coming out the same number, no matter which uniformly moving frame did the measuring. That sameness was the mark of flatness. The fabric was Euclidean, and a rigid lattice of rods and synchronized clocks could be laid across it, everywhere at once, naming every event by coordinates that meant exactly what they appeared to mean. But a gravitational field bends light, and a ray that bends is a ray whose speed is no longer the same from point to point, and a fabric across which light's pace itself varies is the heated slab, not the cool one. No rigid lattice of rods and clocks can be stretched across it. The construction that worked everywhere on the cool table now fails for the same reason. The squares failed near the heated center. What remains is the Gaussian device, applied without restriction. 4 numbers assigned to every event. Numbers chosen arbitrarily, carrying in themselves no claim to mean a place or a moment. Not even a claim that 3 of them are space and 1 is time. And once coordinates have given up that claim, what is left that still means something? Only this: where two such numbered threads, the histories of two material points, traced as lines through the four-dimensional fabric, cross and encounter. Every physical statement, looked at closely enough, turns out to be nothing but the report of such a crossing. A hand and a stone meeting, a beam of light and a mirror meeting, the hand of a clock and a mark on its face meeting. The coordinates that locate the crossing are arbitrary. That the crossing happens is not. In place of the rigid frame, then, a different kind of reference body. Not rigid at all, free to twist and stretch in any way during its own motion, carrying upon it clocks that need keep no uniform rate, asked only that neighbouring clocks, read at once, differ by amounts shrinking to nothing. As the clocks are brought closer together, such a yielding frame, a mollusk rather than a skeleton, is what a Gaussian coordinate system becomes when given hands and a surface to sit on. And every law of nature, to deserve the name, must hold its form, no matter which such mollusk is used to state it. From here, the shape of gravitation itself can be built. Begin with a domain where no field exists at all, where rods and clocks behave exactly as the earlier theory describes, and free bodies travel straight and steady. Refer that same domain instead to a mollusk, to coordinates that twist, that accelerate, that are not rigid. And a gravitational field appears where none stood before, a field of a particular kind, produced by nothing but the change of coordinates itself. The behavior of rods, clocks, and free bodies under this field is now known by transformation alone, and a hypothesis follows that rods, clocks, and free bodies obey this same behavior under any gravitational field, even one that cannot be talked into existence by any change of coordinates, even one that is simply there, anchored to a real mass. The law governing such a field, generalized so that it holds for every choice of mollusk, so that only a body's energy, its inertial mass, determines what field it excites, and so that field and matter together keep their energy and momentum fixed between them. This is the law of gravitation, arrived at without borrowing anything from outside the theory itself. Where the field is weak and the motion slow, this law does not compete with the old one. It produces it. The inverse square pull that Newton could only assume now falls out as the first approximation of something deeper, unforced, required rather than supposed. But a first approximation leaves a remainder, and the remainder has a name. Mercury's orbit, corrected for every influence already known, does not stay fixed against the distant stars. As Newton's ellipse would demand, it creeps slowly in the direction of its own motion, by an amount fixed since the time of Leverrier at 43 seconds of arc each century, a residue too small for the old mechanics to explain by anything but assumptions built for no other purpose. The new law, asked for that same number, returns 43 seconds of arc per century. Not approximately, not in the right direction only, but the figure itself Exactly. For this one planet and no other. Because no other planet sits close enough to the sun for the effect to rise above the noise. Starlight grazing the sun's edge, predicted to bend by a fixed small angle, was found bent by that angle. When a 1919 eclipse let the nearby stars be seen at all, the spectral lines of light from massive stars, predicted to sit shifted from their terrestrial positions, were found shifted in 1924 by the amount foretold. A century-old anomaly, a bending of starlight, a shift in the color of distant light. 3 separate measurements, none of them about geometry on their face, all of them falling into agreement with a theory that had been built from the start as nothing but a statement about geometry. The marble slab, heated unevenly, was never a flat surface pretending to be curved. It was a curved surface, and the rods upon it were only telling the truth. Space-time, in the presence of mass, is that slab. Gravitation is not a force reaching across it. Gravitation is its shape, and the shape, once written down honestly, turned out already to contain the orbit of Mercury, the bending of light at the sun's edge, the color of starlight from across the sky, waiting there to be read off. Exactly the moment anyone thought to look. Stars scatter outward in every direction, and however far the journey runs, the scattering does not thin toward emptiness, nor thicken toward any center. The same crowding, the same average density, repeating at every distance reached. This is the simplest picture available of everything there is. A universe without a middle, because nowhere does the swarm give out. Set beside the law that has governed every falling stone and every wandering planet, this picture will not hold. That law gathers the pull of masses across whatever distance separates them, weakening but never vanishing. And an arrangement of stars with no edge and no thinning sums those pulls into something that cannot be summed. A field strengthening without limit as the region considered grows larger. The count of lines converging on any single point, from an infinite swarm climbing past every bound. The law that bends planets into ellipses, asked to account for everything at once, returns an impossibility. What the law asks for instead is a center, a place where the crowding of stars reaches its greatest, thinning outward from there until, at last, the stars give out altogether, and a region of nothing takes over, stretching away forever. An island, finite, adrift in an infinite emptiness. But an island of stars, finite, and alone is an island that loses something it can never recover. Starlight, leaving its edge, crosses into the surrounding nothing and does not return. Star after star, following the light outward, the island growing steadily poorer, with no mechanism anywhere to replace what is lost. A universe built this way, is a universe bending itself, and has been since before anything began. One way out has already been tried, not by changing the picture, but by changing the law. Let the pull between masses fall away faster than the old rule demands, steeply enough that at the truly vast distances separating the great gatherings of stars, the pull becomes negligible long before it could sum into anything infinite. The uniform, edgeless swarm can then stand after all, each star answering only to its near neighbours, the far ones rendered harmless by the steepened fall-off. The fix works in the narrow sense that the arithmetic no longer breaks, but the steepening itself answers to nothing. No observation calls for it, no deeper principle requires this fall-off, rather than some other, gentler or steeper, chosen instead. A law adjusted only so that its consequences become bearable is not a law discovered. It is a law issued, and any number of others might have been issued in its place with equal justification, which is to say, none at all. The difficulty does not lie in the stars, or in their arrangement, or in any law about how they pull on one another. It lies in the shape silently assumed beneath all of it, that space itself stretches away without limit, flat and endless, the same in every direction forever. A stage too vast for any arrangement of matter to fill or to close. That assumption is not the only one available. Picture an existence confined entirely to a surface. Flat beings, flat rods, a flat world with nothing above or below it, every measurement and every construction carried out within the surface alone and answering only to it. Let that surface be an unbounded plane, and the beings upon it have a universe that is, like the one assumed a moment ago, infinite. Room enough for squares built of rods to repeat without end. No journey long enough to reach a place where the rods run out. Let the surface instead be a sphere. The beings upon it notice nothing different at first. Their rods still lay end to end, their constructions still close into shapes, but a line drawn as straight as a rod can make it, extended far enough, curves back and joins itself. What a being confined to the surface calls straight, a vantage outside the surface would call a great circle, a closed loop of finite length. The whole surface can be measured, tiled, traversed, and the tiling comes to an end, not at a wall, not at an edge, but simply by returning to where it began. The surface has a definite size, and nowhere upon it does anything stop, nor must the beings travel the whole way around to learn this. Mark a point, and from it draw lines of equal length radiating outward in every direction across the surface. What passes locally for straight lines? Join their farthest ends, and the joining traces what passes locally for a circle. On a true plane, the length of that joining divided by the length of one radiating line returns the same fixed ratio. Regardless of how far the lines were drawn, the ratio carved into geometry since its beginning. On the sphere, the same division returns something smaller, and smaller still as the radiating lines are drawn longer, the shortfall growing in exact proportion to how large a piece of the sphere those lines have come to span. From that shortfall alone, measured on a patch small enough that no journey around the world is needed, the size of the whole sphere can be read off. A being need never leave home to learn the size of its universe. The local geometry already carries that number, written into how circles fail to keep their ratio. The sphere is not chosen arbitrarily among closed surfaces. It alone offers every point the same standing as every other. No point nearer an edge, no point more central. The ratio between a circle and its radius depending only on the radius itself, and never on where the circle was drawn. A surface answering to this description everywhere is a surface of constant curvature, and the sphere is its simplest form. What holds for a surface holds one dimension higher for a space. A three-dimensional analogue of the sphere, discovered by Riemann, offers the same standing to every point within a volume rather than across a surface. Lines radiating from any point, extended far enough, converge again at a single far point. The whole space measurable, finite, and without any boundary anywhere along the way. A companion form exists as well, in which those far convergences are identified rather than distinct. A curved space carrying its own kind of symmetry about every point. Either way, the lesson of the sphere repeats one dimension up. Finite need not mean bounded, and a space can be entire without anywhere being its edge. Whether the actual universe answers to any of this is no longer a matter of which picture seems more elegant. The general theory has already shown that the behavior of rods and clocks bends wherever matter is present, and a universe containing matter at all, however thinly, however unevenly scattered, cannot be the flat, endless stage assumed at the outset without contradiction. A universe built on that flat assumption, calculation shows, could carry only an average density of matter equal to nothing at all, a requirement the actual universe, filled with stars, plainly fails. Spread that matter uniformly instead, and the geometry the theory returns is no longer flat, but spherical, or its companion curved form, closed, finite. The rods themselves tracing out a world that returns to itself given distance enough. The real distribution of matter, clumped into stars and the spaces between them, will not match any uniform spread exactly, and the geometry it writes will not be a perfect sphere. But the departure is local, the way the slab heated only at its center departed from flatness only near the heat. Taken as a whole, the universe built by its own matter is quasi-spherical, finite, closed, its size fixed by nothing external to it, but by one quantity alone. How much matter on average, fills it. An equation ties the two together directly. Size on one side, average density on the other, each answering for the other. The light that bent past the sun by a fraction of an arcsecond, scaled up from one star to every star there is, becomes this, a curvature summed across the whole of everything, folding the universe back upon itself until it closes. Not into a wall, not into an edge, but into a shape with no outside, no center, and no place where it stops. The island has not vanished by being made larger. It has vanished by being made whole. Whether the actual figure, the true average density, the true size folded out of it, describes a universe genuinely finite, spherical, or nearly so, or whether the available reach of observation is too shallow to tell it apart from the flat and endless picture it replaces, is not yet settled, and is not pretended to be. What has changed is narrower and more lasting. The question itself, which arithmetic alone could never pose without breaking, can now be asked and, with care and with instruments, answered. Not with certainty, but with the kind of moderate confidence that turns a paradox into a measurement. The rod that opened everything, laid end over end along a railway embankment to mark off a distance, has been laid at last against the whole of space, and the reading is left where the evidence leaves it, open, awaiting only a longer rod or a clearer sky. The script was based on the book Relativity, the Special and General Theory, authored by Albert Einstein and first published in 1917. Thank you for watching. Until the next journey begins.